This lesson will be on 10-3 radical equations. So in example 1, we're given the equation t equals radical h over 4. We're also told that t is equal to 2.5 seconds. So if we set up our equation and we substitute in 2.5 for t, we'd have 2.5 equals radical h over 4. Now when solving a radical equation, what we'll need to do is isolate our radical sign. We need to isolate our square root sign. So we need to move this 4 to this side with our 2.5. We'll do that by multiplying both sides by 4. 4 divided by 4 will cross off here, and 4 times 2.5 is 10 equals radical h. Now we know that whatever we do to one side of our equation, we have to do to the other side. In order to make radical h become just h, we'll square that. And if we square the right side of our equation, we also need to square the left side of our equation. So 10 squared is 100, and radical h squared would give us h. And now we know that h equals 100. Well, you should always be plugging your answers back into your equation to make sure that it works. So 2.5, actually let's do this in another color to check our work. 2.5 equals the square root of 100 over 4. The square root of 100 is 10 over 4, and that equals 2.5. 10 over 4 reduces to 5 over 2. 5 over 2 is 2.5, and 2.5 is equal to 2.5. So that we know that h does in fact equal 100. In example 2, we're given the radical equation, the square root of x plus 1 plus 7 equals 10. As always, we should first start by isolating our radical. So what we'll do is move this 7 to the opposite side with our 10. We'll be doing that by subtracting 7 on both sides. We'll have radical x plus 1 equals 3. Now that we have the radical isolated, we'll be able to square both sides. Radical x plus 1 squared will give us x plus 1, and 3 squared will give us 9. Now we can solve our equation by subtracting 1 on each side, so that x equals 8. We need to plug this into our original equation to check our work. So if x is 8, we have the square root of 8 plus 1 plus 7, and we need to make sure that that equals 10. So 8 plus 1 is 9, and the square root of 9 is 3. So 3 plus 7 does equal 10, and we've checked our work. In example 2a, we're given the equation radical x minus 3 minus 2 plus 4. We'll start by isolating our radical sign. We'll need to move this 2 to the opposite side with the 4. Our equation will become radical x minus 3 equals 6. And now we can square both sides. The radical x minus 3 is x minus 3, and 6 squared is 36. We can finish solving our equation by adding 3 to get x equals 39. And as always, we should be checking our work. 39 minus 3 minus 2 equals 4. Well, 39 minus 3 is 36. The square root of 36 is 6. We still have minus 2. 36. The square root of 36 is 6. And 6 minus 2 does in fact equal 4. So this checks out. In example 3, we'll be solving the equation radical x plus 2 equals x minus 4. We would always start by isolating our radical sign, but in this equation, radical x plus 2 is already by itself. So we can move on to squaring both sides. When we square radical x plus 2, we'll get x plus 2 equals. Now, x minus 4 squared will become x minus 4 times x minus 4. And we would find the product of these two binomials by using the distributive property. X times x is x squared. X times negative 4 is negative 4x. Negative 4 times x is a negative 4x. And negative 4 times negative 4 is a positive 16. We'll then combine our middle terms here to get x squared minus 8x plus 16. And let's bring down the x plus 2 on the left side of our equation. Now, in order to solve this equation, we'll need to move everything to one side. So we should move everything to the side so that x squared is has a positive coefficient. So let's move this x to the right side of our equation. And as well, the 2 will move to the right side of our equation. Our new equation becomes 0 equals x squared. Sorry about that, guys. This should be a minus x and a minus 1x. I was getting a little ahead of myself. So a negative 8 and a negative 1x is a negative 9x. 16 minus 2 will give us a positive 14. Now, because we have a quadratic equation here, we'll be solving by factoring. The factors of 14, we're looking at the factors of 14 that add, right, to a negative 9. So when we look at this, 14 times 1, 2 times 7, 14 and 1 add to 15, 2 and 7 add to 9. Remember that the positive 14 here tells us, right, that we had the same signs, and we're adding to a negative 9, so they both had to be negative. So 2 and 7 are the factors that we were looking for, and this will be factored into 2 minus 7, x minus 7, and x minus 2 equals 0. And now we'll be solving our equation by setting each one of our factors equal to 0. So if we have x minus 7 equals 0, we'll add 7 to both sides and get x equals 7. If we have x minus 2 equals 0, we'll be adding 2 to both sides to get x equals 2. Now we do need to check both of our answers by plugging our answers into our original equation. This is a must for this type of equation because one of these answers or both of these answers may not work. We may have done everything correctly, but one of them may not work. So 7, if we plug a 7 into our original equation, we'd have the square root of 7 plus 2. 7 plus 2 is 9. That has to equal 7 minus 4. 7 minus 4 is 3. Well, the square root of 9 is 3. So 7 checks out and 7 is an answer. Now 2. We'd have 2 plus 2 in the square root sign to get 4 equals x minus 4, and our x was 2. Well, 2 minus 4 gives us a negative 2. The square root of 4 is 2. So the square root of 4 is 2. Does that equal, and this gives us a negative 2. This does not check out. So x equaling 2, even though we did everything correctly, this is not a possible answer because it does not check out when we plug the value in. So our answer in this radical equation is x equals 7.